Welcome to today's video. Today we're going to be focusing on finding the slope of parallel and perpendicular lines, and we're going to show that mastery in class by scoring at least a 70% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet and we'll get you a fresh copy tomorrow. Now, the important thing to keep in mind when it comes to parallel and perpendicular lines, if two lines are parallel, then their slopes are going to be the same. And parallel just means that they're never going to touch. Our symbol for parallel is going to be two straight lines right next to each other. And if you think about the word itself, parallel has two L's. That means that that's our symbol. It's just a good reminder that if you see that, that's what it means. Now, if two lines are perpendicular, and perpendicular means that they meet at a right angle, then their slopes are going to be the negative reciprocal, or sometimes you'll hear it called the opposite reciprocal. Now, the word reciprocal just means you need to flip your fraction. So, if we talk about the reciprocal of 1/2, if I opposite reciprocal it, the reciprocal becomes 2 over 1, so it would be negative 2 over 1. If I have negative 7, technically I can make this into a fraction by putting it over 1. My opposite reciprocal would become 1 over 7. So it's going to be called both the negative reciprocal and the opposite reciprocal, because if it starts negative, it needs to become positive. If it starts positive, it needs to become negative. Now, their product is always going to be negative 1. So if I were to multiply negative 7 times 1 over 7, and 1/2 times negative 2, I would get negative 1. Now, our symbol is going to be an upside down T. It looks perpendicular. They're meeting at a right angle. So the symbols, although they're basic, they look like what they stand for. So now we're going to start with some basic practice. Given the two slopes, determine if the lines are, and again our symbols, the first one is parallel, the second one's perpendicular, or neither. Now, if I look, my first slope is negative 4. Well, if I make that into a fraction, it becomes negative 4 over 1. For slope 2, I have 0.25. Well, if I make that into a fraction, it is 1 over 4. In order for them to be parallel, they have to be the same. Well, these are definitely not the same. In order to be perpendicular, they have to be the opposite reciprocal. Well, if I take negative 4 over 1 and I flip it and make it positive since it's negative, I get 1 over 4. So these two lines are perpendicular. If we look at number 2, we have 0.75. Well, if I turn that into a fraction, it becomes 3 over 4. If I look at slope 2, I have 6 over 8. Well, we always want to reduce our fractions down. This becomes 3 over 4. 3 over 4 is the same as 3 over 4, so those two lines are parallel. Don't forget, if you multiply, you should get negative 1 if they're perpendicular. For parallel, we can't check the multiplication part, but they're the exact same number. So it's just little tricks to help you along the way. Now, we want to determine if AB and CD are parallel, perpendicular, or neither. Now, when we say AB, that means I need to use those 2 points together and find their slope. So if I do that, however you choose, you can graph it, you can use a table, you can use slope formula. I'm going to do 3 minus negative 2. 3 minus 1 becomes 5 over 2. Now, we want to know if it's parallel, perpendicular, or neither to CD. Again, I'm going to find my slope. So 3 minus 1 over negative 1 minus 4. 2, and we have negative 5. Well, the lines are definitely not parallel because they are not the same number. However, if I take 5 over 2 and I take the reciprocal, it becomes 2 over 5, and I have one positive and one negative, these two lines are perpendicular to each other. And if I were to multiply 5 over 2 times negative 2 over 5, that gives me negative 10 over 10, which equals negative 1. So it works, and that's just one simple way to check yourself. Now, if we look at number 4, again, I'm going to find the slope of AB, however you choose to find it. 2 over 4, which equals 1/2. Well, that's my slope for AB. Now I need to find my slope of CD. -3 over -6 simplifies down. And this is why it's important to always take your slope and simplify it as far down as possible, because that's the only way we can compare things, if they are in their simplest form. Well, I have 1/2 and I have 1/2, making those two slopes parallel to each other because they are exactly the same number. Now, this question asks, and it gives us an equation, find the slope of a parallel line and find the slope of a perpendicular line. Well, if I look at these are in standard form. I can't find my slope from standard form, so I need to turn both of them into slope-intercept form, and then I'm just going to look at my m. So if I start with number 5, I have 3x plus 3y equals 72. If I turn it into standard form, I'm doing the opposite, so 3y equals -3x. So y equals -1x plus 24. Now that is my slope-intercept form. But again, I'm not worried about my y-intercept. The only part I'm worried about right now is my slope. So if I need a parallel slope, parallel, again, as a reminder, is the same slope. So if my slope in slope-intercept form is -1, my parallel slope is -1. For perpendicular, it's going to be our opposite reciprocal. So I need to flip my fraction, and if it's negative, make it positive. If it's positive, make it negative. Well, if I have -1, I can write it as -1 over 1. Well, if I flip it and do the opposite, it becomes 1 over 1. 1 divided by 1 is 1. And if we multiply -1 times +1, we get -1. So we know we're correct. Now, if we look at number 6, again, it's in standard form, so we need to turn it to slope-intercept form. So, slope-intercept form, y equals -1/3 x minus 6. Again, we don't care about the y-intercept. All we're worried about right now is my slope. And my slope in this case is -1/3. So when we talk parallel slopes, it has to be exactly the same. Well, the same thing as -1/3 is -1/3. My perpendicular slope, I'm going to take my -1/3 and I want to flip it so it becomes 3 over 1. And since my first slope was negative, my second slope has to be positive. And again, now we need to simplify it. 3 divided by 1 is 3. All we care about, and we keep going back to the slopes, is those slopes. The y-intercepts don't affect whether they are parallel and perpendicular. Parallel lines never touch. It doesn't matter where it crosses the x-axis or the y-axis. Perpendicular slopes meet at a 90-degree angle. It doesn't matter where they cross the y-axis. They can meet at a 90-degree angle at multiple spots. So that's why we're not worried about the y-intercepts. We're just focusing on those slopes. Now, the last type of problem. Using the line and the point given, find the missing point so the slope of the line is parallel. So that's important. They are the same, and we need them to never touch. So, my first step, I need to find the slope of my line. Now, you can do it by graphing, using the graph that's given. You can do it by picking out 2 points. However you feel comfortable finding the slope. If I look, I'm going to go up 2, and I'm going to go to the right 3. Up 2 to the right 3, up 2 to the right 3. So, if I'm going up, it's +2. If I'm going right, it's +3. So in this case, no matter how you do your slope, m is going to equal 2/3. It's rise over run. If you pulled 2 points, you should still get the same slope. Now, step 2, we need to determine our new slope. Well, in this case, because it's parallel, it's got to be the same thing. So my new m is going to stay 2 over 3. My third one is we're going to start at the point and we're going to follow my slope. So if I start at point P and I do positive 2 over positive 3, I go up 2 and over 3. There's my next point. I can go up 2 and over 3, up 2 and over 3. And if I were to connect these dots, we notice that my 2 lines never intersect each other. And that's what parallel lines are. So now we know we did our question correctly. If the lines crossed at any point, we knew we made a mistake somewhere because parallel's never supposed to touch. Please bring these notes and any questions you have to class tomorrow. We'll continue going over this. I look forward to seeing you then.